This is one of the models the way we can create it. It is a model microwave. It has 5 switches. The switch in the bottom left corner is the start and stop switch, which starts or stops the timer. The switch in the top left corner is the 5-second timer switch, which adds 5 seconds to the timer. The switch next to it is the 1-second timer switch, which adds 1 second to the timer. And the switch in the bottom right corner is the reset timer switch, which resets the timer back to 0. There is also one more switch, which is the door limit switch. When it's delatched, the door will be in open state and the LED will be turned on. When it is pressed, the door will be in closed state and the LED will be shut off. It is controlled by this magnet here, which attaches to this rod here. And the thing that's pressing the switch is these 2 blocks right here. Now let's add some time to the countdown to see the microwave functioning. Now we can stop the timer, add some time if we want to, and then restart it. We can even stop the timer by opening the door. And then when you press it, it resets the timer back to the original time, and then you can press the start button again. You can also stop the timer and then reset the timer back to 0. And start again. Stop. When we open the door and start the timer, a buzzer will go off indicating that the timer cannot be started. This also applies when there is 0 time in the timer and the user tries to start the system. Let's add 3 seconds to it and see what happens. The buzzer will beep 3 times, indicating that the timer has run out. Let's take a look at the VI for the microwave. First, I would like to mention that there's a legend for the input-output port numbers. And there's the code itself. The code is running a basic state machine in which states change based on the user input. Since it is in a while loop, it will loop on forever until it has been stopped. The user can stop the program by pressing the Stop Program button on the front panel. Also on the front panel is the current state indicator, which indicates what state the code is currently. The first state is the initialized state, and the next state is the closed state. From the closed state, it's going to execute the sequence and check for the door. If the door has been opened, we'll go to the open state. If not, it'll check for the timer inputs. Let's take a look at the open state. It's very similar to the closed state, but instead it will turn the LED on, meaning that your LED will be on when the door is opened. Again, it's going to check for the door switch. If the door switch has been pressed this time, it will go to the closed state. If not, we'll check for the buttons for the timer values and go to that state accordingly. Let's say that the user decides that it's 5 seconds, we'll go to the 5 seconds, adds 5 seconds to the timer value, and goes back to the last known state. Now, if a limit of 30 seconds has been reached, a buzzer will go off, indicating that you can no longer add any time to the timer control, and goes back to the last known state. The user can also add 1 second to the timer. Again, it's very similar to the 5-second state and goes back to the last known state. Let's take a look at the start state. First, it's going to check if the door is open or not. If the door is open, we'll ring the buzzer and go back to the open state. If the door is closed, it's going to check if the timer value is 0 or not. If it is, it's going to ring the buzzer and go back to the closed state. If the timer value is not 0, it will go to the on state. In the on state, it will start the timer and the countdown and turn the LED on and the motor on, which can be found in the true case. Now, while the countdown is running, it's going to check if the door switch has been delatched or the start-stop button has been pressed. If it is pressed, it'll go to that state accordingly. When the timer has run out, the LED in the motor will shut off, the timer and the countdown will set back to 0, a buzzer will go off 3 times, and it will go back to the closed state. This will loop on forever until the user decides to add time, stop time, or end the program itself.